Hello, this is question 3 from the Step 2 paper from 2022. Fibonacci numbers defined by F00, F1 is 1, and then the usual way of constructing the Fibonacci sequence. Just glancing at this, I don't think I'd pick this question if I was doing it in the actual exam. I was doing the actual test. Part 2 looks quite unpleasant, which concerns me that part 3 and 4 might be even worse, but still. I'm going through all of them, so I'll go through this one. Part 1, prove that fr is less than or equal to 2 to the r minus n times fn for all n is greater than or equal to 1, all r is greater than or equal to n. Okay, so right, let's write out a bit of this sequence. I always like looking at them if I can. So that is how we're kicking off first, whatever that is, 9 terms or whatever. So we need to prove that. So r is greater than or equal to n, so it can start at n, in which case we've got fn is equal to fn. And then as r moves further away from n, we're increasing that power of 2. So it's saying that we can't just keep on doubling the numbers. Well, we can't. We can do it once here because we've got 2 1s, which give us a 2. But otherwise, we can't. So how am I going to build that up then? So I want to say that what have I got then? Fn plus 1 is greater than or equal to Fn. That's something which has got an inequality in it. So yeah, that's definitely going to be the case. And we've got Fn plus 2 equals Fn plus 1 plus Fn. So that must be less than or equal to 2 lots of Fn plus 1. Right, okay, this has brought a 2 in. And yeah, we got R's, we got N's. Okay, so if I'm saying then that Fn plus 1 is less than or equal to 2Fn, I've got Fn plus 2 is less than or equal to 2Fn plus 1, so it must be less than or equal to 4Fn, okay, which is 2 to the n plus 2 minus n times Fn. Okay, so yeah, that's just built up. That's done it then, isn't it? So, and so on. And we could say Fr would be less than or equal to 2 to the r minus n Fn. Yeah, in general, we can have that. Yeah, so we can't be doubling up. That's the only time we double up is when we've got 2 Fibonacci numbers that are the same as each other, next to each other. So if we got a 1 and a 1, we get a 2. But as soon as we break that position of having 2 numbers that are the same, then we must always get then a less than. We're not doubling up a term. It's always going to be less than double the previous term. Okay, so that was fine. Right, this second part looks like it's going to be pretty intense. So I'm going to do a new sheet for this because there's so much of it. So we've got Sn is that. So this is the sum from 1 to n of a Fibonacci number divided by 10 to the power of the position of the number in the sequence. So that's going to be some pretty small numbers. And then I need to show all of this. Some sum minus these 2 sums is equal to that. So they've all got 10 to the r minus 1 on the denominator. They're all going from 1 to n for r. And we've got an fr plus 1, an fr, and an fr minus 1, which are related by the Fibonacci sequence. So fr plus 1 is fr plus fr minus 1. So that's equal to 0. Interesting. Yeah. Okay, I'm going to make a note of that because that probably is going to be useful. Since fr plus 1 equals fr plus fr minus 1, the left-hand side equals 0. Right, but that doesn't help me get the right-hand side because I haven't got any SNs in it. And I need... Am I trying to get these things in terms of R's? Or do I want to get the same, like, and do I want to have an FR plus 1 with a 10R plus 1 on the bottom? As in, do I want to get those the same? Is this about having the R's the same here? Or do I want to get everything? Actually, I can change the R's by moving these limits around on the series, can't I? So, okay, let's have a bash with this then. So the sum from R equals 1 to n of FR plus 1 over 10 to the R minus 1. So I want to get that, first of all, with all R plus 1s. So I'd have to multiply by 100. That would get me R equals 1 to n F R plus 1 over 10 to the R plus 1. Yeah, so I've multiplied top and bottom by 100. Now I can shift that R by going from, so I'd want to do 100. I'm going to want to change the limits on this to make that an FR over 10 to the R. So R, I'd need to start, rather than at 1, I'd have to start it at 2, and I'd have to go to n plus 1. Right, okay, that's fine. And that is what? That's very nearly Sn. So that is equal to 100. But we've got to take off the R1 and add on the n plus 1. So I'd have an Sn, and then I'd have the R1 term I've got to take off. So that's F1, which is 1. Oh, they've left it as F1 in here, so I'll leave it as F1 then. Okay, F1 over 10. Okay, so that is going to give me that term, so that's pleasing. And then I've got to add on the Fn plus 1 over 10 to the n plus 1, which is going to give me the last term. Right, okay, this is the way it goes then. So that middle one is going to be, I just need to multiply that by 10, and I've got Sn. So that is 10 Sn, that middle one. And then this last one then, so I don't need to multiply by anything, do I? So I'm going to be doing, because they've already got the same R minus 1, but I need to drop it down to 0 this time. So I'm coming downwards to 0 and then minus 1. So that's going to then be well, f of r over 10 to the r. So that is equal to Sn, and then I have to take off the 0 one, which is nothing, and I need to add on Fn over 10 to the n. So all in all then, I've got, what have I got? I got 100 Sn minus 10 Sn. So I've got 100 minus 10 minus 1, lots of Sn. I've got a minus 10 F1. I've got a plus Fn plus 1 over 10 to the n minus 1, because I'm multiplying by 100. And I've got a plus Fn over 10 to the n. So, which is equal to 89 Sn minus 10 F1 plus Fn over 10 to the n plus Fn plus 1 over 10 to the n minus 1. Wonderful. Okay, right, so the bit that put me off the question wasn't actually that bad, but I still wouldn't have picked it. So onwards then with part 3. Show that the sum from 1 to infinity of fr over 10 to, so that's not Sn, that's S infinity, is 10 over 89. And that the part of that sum starting at 7 is less than 2 times 10 to the minus 6. Hence find with justification the first 6 digits after the decimal point. Okay, so we've got, let's write the series out again. So 0, 1, 1, 2, 3, 5, 8, 13. That's probably enough because we're only going, this 7 is going to be relevant here. So we're doing this there. So yeah, we've got 1 over 10. Then we're adding on 1 over 100. Then we're adding on 2 over 1,000. Then we're on 3 over 10,000. So we're building up that. And the problem comes in when we get a 13 and we stick it on there. And now we're not just going to the next decimal place, we're overlapping. So, and that's going to be the 7th one, is it? 1, 2, 3, 4, 5, 6, 7, 8th one. Oh yeah, we're starting at 0, so that is F7. So that's why we're getting an issue. So how am I going to get S infinity? So I've got all of that, and I know that's equal to 0. So I've got 89 Sn is equal to 10 F1, which is 10, plus 0, minus Fn over 10 to the n, minus Fn plus 1 over 10 to the n minus 1. And I want S infinity. Well, these second two terms are going to disappear because we've got 10 to the infinity on the bottom. So that will, okay, as n tends to infinity, the last two terms go to 0. Therefore, 89 S infinity is equal to 10, which means we've got our S infinity is 10 over 89, which is what we want. So that bit was fine. Now we've got this inequality. The inequality is a bit annoying, isn't it? Yeah. So the inequality is, well, the only place we've had an inequality up until now is here. So it's got to be to do with that, hasn't it? So I've got going from r equals 7 to infinity fr over 10 to the r. So I've got that. I don't like the fact that I've got 7 there. That looks really annoying because it's stopping me from doing a sum to infinity. So do I want to pull this down to, what do I want to pull it down to on the inequality? Do I want to put it down to 1 or 0 is what I'm thinking. Is it going to mess up? If I'm using this thing, a 1 might end up causing a problem, might it? I'm not sure it would actually. But anyway, I'm going to go to 0 just to be safe on it. So that is equal to r equals 0, because I mean the 0 doesn't make any difference to this, so I might as well put it in because it's only adding nothing to the total, and it means I'm definitely not going to cause problems with those. And I know that fr plus 7 is less than or equal to, I want f, what do I want on there? I want f7 there because I don't want it to be an r. I want the 2's to be inside the sum, so that would be 2 to the r. So that has got to be less than or equal to f7, which is 13, divided by 10 to the 7, because then I'm just keeping r's inside the sum. Right, this is going fine as well. So that would be, not fr, 2 to the r over 10 to the r. Right, so that's fine. This is just a geometric sequence multiplying in fifths starting at 1. So I'm going to have 1 divided by 1 minus a fifth, so that's 5 over 4. So that is going to be 13 times 5 over 4 times 10 to the 7. Great. So that's 65 over 4. So that's 16 and a quarter. And well, I just want to drop that down. So let's say it's 1.625 times 10 to the minus 6, which is less than 2 times 10 to the minus 6, which is exactly what I wanted. Right, hence find with justification the first 6 digits after the decimal point in the decimal expansion of 1 over 89, not 10 over 89. So we've just worked out that, what have we just worked out? We worked out that 10 over 89 is equal to the going up to f6, so that's 0.112358. So that's, yeah, 0, 1, 2, 3, 4, 5, 6, plus some amount, plus something which is less than 2 times 10 to the minus 6. Okay. Plus something less than 2 times 10 to the minus 6. So if we want, so therefore we want 1 over 89 is going to be equal to 0.011238, plus something less than 2 times 10 to the minus 7. So where are we going then? 1, 2, 3, 4, 5, 6, 7. So we can't get up to 8 plus 2. So therefore, yeah, we can't make that a 6 where the 5 is. Therefore, cannot affect 0.011235. Yeah, we could change the 8. The 8 could become a 9, but we can't get the 5 to become a 6. So that's fine. That's a really long-winded way of working out the 1/89. I mean, I'll just do a quick aside here. So this is something, because I was thinking about this the other day, not specifically this, but I was doing a video on the rapid fire multiple choice questions and number manipulation. These are actually really good practice for this. So say you were wanting to work out 10/89 or even 1/89, is all much of a muchness. So let's see how far we can get with this. So you boost it up until you can actually do a division and then say, okay, so we've got 0.01 here. Let's do for 1/89. I've already stuck 2 noughts on the top. We've got 1/89 goes into that, leaving a remainder of 11. So obviously it doesn't go into 11. So let's stick another 0 on there. So we're going back another decimal place. We get another 1 with a remainder of 21. So if we do 2 89s this time, we'll have 178. We'll put a 2 there. So I've now got a remainder of 32, so 320. So I'll be able to do 3 of them are 267 for that. So put a 3 there, which means I've got a remainder of 53, 530. How many 89s can go into that? I'm going to want to do 5 of them for 445, which is giving me a remainder of 850. How many into that? Well, I'm going to want 9 of them for 801, gives me a 9, and then a 490. Well, that's going to be the 445 again, giving me a 5 with a 45 for a 450. So that would be another 445, which would be another 5, which gives me a 5 remainder. So now I'm going to have to boost that up twice. So I'm going to have a 0. So you can see how this is going. But in next to no time, I've built up, how many decimal places is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 decimal places for 1/89. And that's probably taken, I don't know, maybe a minute or something. I didn't exactly have a stopwatch on it. But it's really good practice, that, for number manipulation. You can do a similar thing with square roots. So pick an irrational number, do the square root of it. Again, you'll be multiplying lots of things by 100 in here. Because then when you're square rooting it, you're getting 10s on the outside. But you can do a similar sort of thing. But in terms of getting some number sense and not losing touch with actually doing a bit of mental arithmetic when you're getting into more and more detailed algebra and these sort of series and things, do something like that. Particularly pick a denominator which is a prime or something, and then just do the reciprocal of it. See how quickly you can get to 10 decimal places. Anyway, that's a bit of a distraction from where I was, but I've done part 3 anyway, so let's get a fresh sheet up again. Go part 4. Find with justification a number in the form r/s with r and s both positive integers less than 10,000, whose decimal expansion starts like this. Geez, right, okay, so we got 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. Right, so we got Fibonacci there. Everything's been pushed back further. We've gone an extra couple of, we've doubled up the decimal places. Let's compare this. What did I provide? 0.011235. So the 1's gone from 2 back to 4 back, and then 3 back to 6 back. Right, okay, so we've just moved it a little bit further back. So we've now got f1 over 10 to the 4 plus f2 over 10 to the 6 plus f3 over 10 to the 8, etc. We're just pushing back an extra, well, double the number of decimal places. So, well, actually, this is why we started with 10/89, not 1/89 on the other one, because we were trying to pull this one back so that f1 was 1 decimal place back and f2 was 2 decimal places back. So we were getting these things aligned, the ones and the tens, because so we were having an F1 over 10. You can see it here. Whereas now we've got this thing. So if I was making these 100s on the bottom, I could say dot 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 there. That's going to be 1 over 100, the sum of r equals 1 to n of fr over 100s to the r. That's what I've got there. Is that the right number of r's? So if I had f1, I'd have 10 to the 4 on the bottom, and then I'm going up in 100s. So I go 10 to the 6, 10 to the 8. Right, so we've got a very similar thing there. So I want to work out this all in all. This is what I'm after. This is pretty much identical to what I did in the previous part of the question. So let's call that, well, it's not Sn, let's call it Tn. And then I'm doing exactly the same thing again. So I can repeat part 2, but these will have hundreds on the bottom rather than tens. So that means then when I go through, what does that mean when I go through all of this? All the tens are going to become hundreds in this, otherwise they're going to be the same, but I'm going to have a different number here for the Tn. So repeating part 2, I don't have to write all of this out again. So I'll come back to what the coefficient of Tn is, but I'm going to have 100 F1s. So that's just 100. The F0 is 0. I mean, they put those in there, but we didn't need them. And then I'm going to have, that's then a minus, isn't it? So an Fn over 100 to the n. I'll have a minus Fn plus 1 over 100 to the n minus 1. So my Tn, what is my Tn going to be on this? So I would have pulled out 2 lots of 100 out of here to get that up to power. And then that will be 1 lot of 100, and that will be a 1. So that's going to be 100 and then times 100 minus 100 minus 1. So 10,000 minus 101. So that is going to be 9899 Tn is equal to all of that. Okay. And then we did, that's done part 2 again. Part 3 again is giving us T infinity. So T infinity will be 100 over 9899. Okay. What did I want to do then? So I need to, I've got this annoying thing that I have to deal with. I need to divide that by 100. So I want then that this is going to be equal to 1 over 9899. Because how far have they gone back? They've gone back. This must be, we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 digits. So that's going up to F11. Is that right? Yeah, F11 for 22 digits. Okay. So, oh no, but it starts at 0. So it's not F11. Oh, getting a mix. Okay, so, right, what have I got? That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. F10. Okay, so I've gone to F10. So now when I'm doing the inequality bit in part 3, I'm going to have yeah, I'm now not sure what number I want on this. This will be going to F11, F10. I'm just trying to think. What did we have here? We were going up to, the 6 was fine and it was 7 when it went wrong. So this would be the next one. That would be F11, sticking with what we did in the previous part, divided by 10 to the 22. Then it's going to be the sum 2 to the r, 2 to the r over 100 to the r, from r equals 1 to infinity, well, 0 to infinity, doesn't matter. Actually, does it matter? Yeah, because in this case it does matter. because we're starting at 1 rather than we're starting at 50. So it does make a difference. So what am I getting for that then? I'm going up in 50ths. So it's going to be 1 over 1 minus a 50th. So 50 over 49 times F11, which is 89, over 10 to the 22. Right, yeah, because before we just had F7 over 10 to the 7, because we got those numbers being the same, and we went for 7 because we had already written out that. We had done the first 7 in the sequence, so going up to F6. F7 was our 13. That was where we cut off because we were then starting to get the problems. So, and now we've got double the power on the 10 because we're going up in hundreds rather than going up in tens. So yes, that's our equivalent on this one. And what do I need to show then? That this is going to be less than 10 to the minus 22. But it's not. So I must have done something wrong then. Oh, but yeah, this is comparing it with the 100. So that's working, comparing on this. So I need to do another times 100 on there. So we're actually comparing it with the 1 over 900. This is to compare with 1 over 9899. Again, we did this last time, not 100 over 9899. Yeah, we did exactly the same thing here when we switched from 10 over 89 to 1 over 89. So again, just repeating what we did before. Right, okay, so I can get rid of that and that. So I can say, what way am I going to do this? Am I going to say that is half of 89? So, okay. So let's go with that then. So 44 and a half. Actually, let's just put it over double the bottom. 89 over 98 times 10 to the minus 22, which is less than 10 to the minus 22. So then I have to do my therefore. Therefore, the subsequent sum, so the sum from r equals 11 to infinity is less than 10 to the minus 22, so will not affect the first 22 decimal places. Okay, right, so that was a kind of weird ending to the question where we just had to repeat everything again, but with 100 rather than 10. So yeah, bit of a strange one, but at least we'd done it all once before, so it was just repeating what we'd already done, which is what made it quite quick. You know, you don't have to write everything out again. You know, repeating part 2 was just writing it out again with hundreds rather than tens, and then repeating. It was a little bit more fiddly repeating the inequality, but I think part of that was I was trying to remember what I'd done. Because it's all on the other sheet. If I had this written on a bit of paper in front of me, it might have been quicker doing that last part. Because yeah, I was just trying to get it straight in my mind what we'd done with these F's. But if I'd had the other bit there written directly in front of me, it probably would have made it a bit quicker. But yeah, not a particularly pleasant question. I certainly wouldn't have picked this, and I think I'm justified in that decision having gone through it. So there you go. That's the end of question 3.